Factor first, here we go. X plus 5, x minus 5. Let's factor that denominator. X minus 5, x plus 4. Okay, you see it, I see it, we both see it. Let's cancel. That means there's going to be a hole in this graph. Just say it. X plus 5, x plus 4. Okay, let's start finding x-intercepts, y-intercepts, holes, vertical asymptotes, horizontal asymptotes, everything. Come in today. Sounds like a used car dealer. We have x-intercepts, we have y-intercepts, we have a hole in our graph. There's a vertical asymptote, there's a horizontal asymptote. If you order now, we'll show you how to find them all. It's at that point that I turned the TV off, so yeah. Just turned you off to this lesson, didn't I? X-intercept is going to happen where the y value equals 0. However, it's important to note that you should always factor and reduce first. So let's, done. Lucky us, okay? So 0 equals, don't use that, do use that. And that's x plus 5 over x plus 4. You want a shortcut? I do. When you cross multiply, 0 times that denominator becomes 0. And then 1 times x plus 5 becomes x plus 5. I'll go ahead and tell you, set your numerator equal to 0. That's what it really is. You can write that in your shortcuts if you like. Actually, let's do that. Numerator equals 0. That's what it really comes down to. Okay, x equals -5 is our x-intercept. Y-intercept. Well, why not? Y is done, wasn't it? Y equals 0 plus 5 over 0 plus 4. That's going to give me 5/4. That's 1 1/4. So we're going to put a dot at 1 1/4. All right. Holes in the graph. X plus 5 canceled. So take that x minus 5. Set that equal to 0 and solve it. We're going to have 5. 5 comma what? I don't know, but we're about to find out. And that thing we're about to find out is what I get when I take the 5 and plug it into the reduced form. So we're going to have 5 plus 5 over 5 plus 4. That's going to be 10 over 9. And that is the y value. Now 5 comma 10/9, that's just a little more than 1. So let's go ahead and put an open circle there. So we're going to have an open circle at 1, 2, 3, 4, 5. And then just a little more than 1, just a wee bit more. Okay, vertical asymptote is where your denominator equals 0. X equals -4. Let's draw that one in red. You shall not cross this line. Okay, horizontal asymptote. You wanted a shortcut? Too bad. Y equals 1. I'm not telling. Fine. I want to know anyway. Notice how close you get to that point with that hole. Same here, but you never touch it. All right, let's draw this thing. It's going to hug along this side. Now, if you're like, I'll just graph this thing in Desmos. Have fun. But where's the hole? Yep. What you going to do when the x-intercepts are crazy decimals and you don't know exactly what they are? Huh? What you going to do then? Huh? You going to cry? Huh? There we go. That's it right there. Let's talk about the horizontal asymptote briefly for real. And I think this is not going to fully answer your question, but it's going to give us a push in the right direction when we get to the next one. Pencil time. Y equals 1. It's 1 over 1. Just saying. Okay? Very first problem we did. Y equals 1 is 1 over 1. Now if you're thinking, okay, fine, I hear ya. Y equals 0. It's 1 over 1. Yeah, no. Okay, so here's, I'm about to say too much. This one, the denominator is linear. The numerator is not linear. Make it linear. This would be x plus 1. Oh wait, I lied. I can't just do that. I have 0 x's. 0 over 1 is 0. Okay, let's talk about the discontinuities. You are going to have 2 of them. If you drew from left to right, you'd go, have to lift my pen. Oh, had to lift my pen again. Now on this one, you had to do a major course correction. That is a non-removable at x equals vertical asymptote, -4. And here, where you would just go blip, we have a removable at x equals whole